So, hi everybody. I'm going to finish this discussion about solutions and solubility with this lecture. The couple things, this slide I want to talk about dissolving. We talked about this a little bit when we talked about chemical bonding. When we talked about intermolecular forces. So the question is dissolving, remember the solubility rule of thumb? Well, that rule, if you can remember, is called like dissolves like. So if I can spell it here, but like dissolves like. So polar substances will dissolve polar substances. So a lot of substances are polar or they have a polar end, and non-polar substances dissolve non-polar substances. So kind of going back to, I think I used this example in class. If you got grease on your shirt, you're just not going to use water to dissolve it. You have to use something that's non-polar. So why does table salt dissolve in water? It has to do with attraction. So when we talk about table salt is NaCl. It has a positive end and it has a negative end. So the positive end, when it is submerged in water, and remember when we think about water is H2O, and the hydrogens have a positive end and the oxygens have a negative end. So we talk about attraction. So the like charges attract, or like charges repel, opposite charges attract. So the chlorine is going to be attracted to the hydrogens. So it's going to surround itself. And the water surrounds sodium. What part of the water surrounds sodium? It's the negative end. Okay. So, when you'll have a paper in your homework that has to do with dissolving, what dissolves what, and you'll have to look whether or not the substance is polar or non-polar. So remember some of the criteria to say if it was polar or not. It's asymmetric. So if it's polar, it's asymmetric, which means the sides are not alike. And if it's nonpolar, it's symmetric, which means they are alike. Okay, so this slide will help you with your homework in the packet on page 1. So we're going to go on now. We're going to talk about solubility curves. Okay, so here's the solubility curve. It says so it's a solubility versus temperature. So if you notice on the y-axis, I have solubility, or grams per 100 grams of water. So the grams per 100 grams of water really talks about how many grams will dissolve in 100 grams of water. And on the x-axis is temperature. So you can tell most of the lines will increase as temperature goes up. Sodium chloride stays pretty constant, so it doesn't matter how high the temperature is. It's going to stay pretty flat. You're only going to be able to, about what you start with, which looks like about 38 grams at 0 degrees, is about what you'll end up with at 75 degrees Celsius. So you don't really get that much of an increase. The one that goes down, this more behaves like a gas. Gases tend to become less soluble as the temperature increases. So this substance here, the solubility is going down. So part of this discussion is to teach you how to read the solubility curve. So describe what happens to the solubility of potassium nitrate as the temperature increases. So I'm looking, the purple line is potassium nitrate. So as the temperature increases, so does the solubility of potassium nitrate. So it increases. Which substance shows a decrease in solubility as the temperature increase? Well, I just said that earlier. This is the YB2. I can't make the 2 here. I gotta no. Gotta redo that. So find my pen. So YB2 SO43. Suppose you add some sodium chloride to a saturated solution of sodium chloride. So saturated means that it can't technically hold any more solute. It can't hold any more salt. And even when it's warmed up to a mixture of 40 degrees. So I'm starting here at 0 degrees, and as I move to 40 degrees, it wants to know, suppose you added some NaCl to a saturated solution of NaCl and warmed up the mixture to 40 degrees. What would happen to the NaCl? Nothing. It would still be formed. It actually would still have salt crystals in the bottom of the beaker, even while you're heating it, because there's too much salt in the solution. What happens if you would add KNO3? So now I have this beaker and I have NaCl in there, and now I'm going to add some KNO3. Well, you can tell by this purple curve here, KNO3 is a lot more soluble as the temperature rises. So what happened? What if you added KNO3? Well, the KNO3 is going to dissolve. The NaCl will not, but the KNO3 will. So will dissolve. Let's talk about, so what pieces of information can you derive from the graph? Well, the one thing you can derive is how soluble a substance is. How soluble a substance is. The other thing you can derive is that NaCl is constant. It's not changing. It's constant. And then the other thing you derive from the graph is the fact that YB2SO43 decreases in solubility. So it decreases in solubility. So now the reason we have solubility graphs is actually to determine if a substance is saturated, unsaturated, and supersaturated. So really, it's pretty simple. So we'll go through the first one. It says 40 grams of KBr at 60 degrees Celsius. So I have 60 degrees Celsius. I got to find KBr, and KBr is this green line here. So I'm going to find 60 degrees, and then I'm going to find 40. So this is where it would be. So if you notice, this blue dot is well below the green line. So if your point on the graph is well below the line of the substance that you're looking at, it's what we call an unsaturated solution. It's unsaturated. Okay. So 100 grams of sodium nitrate. Sodium nitrate at 40 degrees C. So here I have 40 degrees C. I'm going up to the red line, and I'm looking for 100 grams. Well, 100 grams is actually above the red line. So what I need to do is erase this really quick. And then I'm going to go back. I'll pick a different color, purple. This is the 100 grams right there. The purple dot is actually above the red line. So this would be what we call a super saturated solution. So this would be an example of something like rock candy or fudge. So if you let it cool, it would start to form crystals. Okay. And then 100 grams of the same substance. So again, at 45. So I'm just going to go over 5 degrees. So halfway through, and I'm going to move up to 100 grams, and I'm right on the line. So that is what we call a saturated solution. Okay, so let's finish answering some of these questions. If you start with 50 grams of KBr at 80 degrees Celsius, how much more KBr can be added to make it saturated? So I'm going to, so 80 degrees KBr, that's this green line here, and it says if I start with 50 grams. So I'm going to start about here. So, and I have to go to 80 grams, which is up here. So really what you're looking at is the difference between 50 and 80, which is 30 grams. So 30 grams would make it a saturated solution. Anything above 30 grams would make it a super saturated solution. If you put 40 grams of NH4 Cl and 100 grams of water, at what temperature will it all dissolve? So if I look at the ammonium chloride here, and I have 40 grams, so I'm looking at this blue line here, and I want to see at what temperature will it all dissolve. It looks like around 30 degrees Celsius, it will all dissolve. How much water will it take to dissolve 100 grams of NaNO3 at 10 degrees Celsius? Well, if I'm looking here at 10 degrees Celsius, NaNO3, it takes 100 grams of water will dissolve 80 grams of it at 10 degrees Celsius. And if I go back and look at the question, because I do not remember what it said, how much water will it take to dissolve 100 grams at 10 degrees Celsius? It will take 100 grams at 10 degrees Celsius. So it will take 200 grams of water to dissolve 100 grams. So if it takes 80 grams to dissolve 100 grams of water, it's going to take 200 grams of water to dissolve. Oh, actually, nope, that's wrong. It will take, no, that is right. It will take 200 grams of water. It will take about twice as much, roughly. Okay. So that stops the lesson for today. Not tomorrow, next week we'll actually start talking about concentration and molarity.